So why would you want to cube it with WaterCube? WaterCube's offering the first big data processing engine for analyzing vast amounts of river and reservoir data, inclusive of visualization software on the back end for comparing, validating, and measuring progress. WaterCube's enabling you to quickly access this data, making decisions within days of data collection. In this case study, we're going to look at some efforts in hydropower and selection of a monitoring site for quality and flow, as well as some minimum in-stream requirements that were being studied on this reach. By providing a complete workflow, WaterCube can come in and help you with advanced data collection methods utilizing the latest acquisition technology. By providing an innovative processing engine, you'll have your results within days of data collection and you'll be visualizing like never before. So let's take a look at the Snake River and CJ Strike Dam. On the left, there's line plans for where the measurements were to take place, along with some further defined areas that were being studied in greater detail, what we would call subcubes. The ADCP track lines are outlined here. Acoustic Doppler profilers were utilized, multiple in fact, streamwise along this river reach, and then we went back and also did this crosshatch pattern for the higher density coverage area for the study specific segments for the subcubes. By combining ADCP bathymetry and the LiDAR, we produced a complete topography of that entire area. In doing so, we then layer in the velocities throughout that entire reach, and you can study that throughout the entire column of water. By creating the digital elevation model, we lay in all of the velocity vectors within the entire study area of interest, along with the LiDAR that were brought together for the digital elevation model. At that point, you can analyze any of these velocity profiles, pulling them out at specific sites at any cross-section. So you can compare and contrast over time and to see what's really happening within your river. Subcubes are done with higher precision data collection as well as processing, so that you can have a much more granular view of your data and potentially use them for model calibration. This is an example of the subcube taken at the Snake River, where they were planning to put in an actual instrumentation device to measure some of the in-stream flow.
Here we're in Cubeit Professional, where we've brought in the DEM of the CJ Strike Snake River example that we talked about earlier. So we have the DEM, we've overlaid the slices that comes out of WaterCube, but here we also have the actual volume data for the full reach of the data. So if we kind of pan back out, we can kind of, for context, kind of see the orientation of where we are. You can see the spillway on the left there, and then the turbines would be on the right, and then those two paths kind of feed into the main river. And you can kind of see in the DEM a little bit where the bridge would be crossing over the section of the river. So this gives you a dynamic view of looking at the data. So we're looking at slices that were overlaid in the DEM. We're also able to look at the elevation slice. So now we'll kind of step through the elevation cut within this reach, and you can look at the velocity profiles that are occurring. One thing that this does is it gives you a good representation of kind of the flow field, where you can kind of dive down and kind of see where the main flow is. But the key here is, we've overlaid the DEM, the slices, the volume data, so now you can really interactively explore the data from WaterCube. And I'll hand it over to Art to kind of add his comments on how various target end users could benefit from this type of interactive visualization. Art?
Thank you, Tom. Well, just looking at this, a lot of things stand out to me. Just from understanding what's happening in the flow, these slices we're looking at right now, the one we have right up, you can clearly see a low velocity eddy behind a a rise in the stream bed there. So what we're getting is a lot of information that you don't see if you're just doing your standard transects. This ability to look at different depths, different levels is very powerful. You know, one application I think of is just hydrometry. It was mentioned that this is a velocity indexing site. Velocity indexing, for those who don't know, is a tool to get a discharge rating, a continuous flow record at sites where, because of backwater or regulation, a standard stage discharge rating won't work. So you measure your velocity with generally an acoustic instrument at a small subset of a cross-section, and then you develop what's called an index velocity rating that relates that index velocity to the mean velocity in the cross-section so you can get discharge. The key assumption is that wherever you're measuring has a very constant relation between the velocity there and the mean in the cross-section, and that you have a strong signal-to-noise ratio, so you have a high velocity area. So these slices right here, as I'm planning a site like this, I can look at how does my velocity behave. Where do I have that strongest ratio? Where do I have something, again, maybe some change in the bathymetry that's going to affect this relation, and I won't get a good measure. There's other things that we can do. In a lot of parts of the country, probably not at CJ Strike with the granite outcrops, but a lot of the country, we're worried about scour of bed material. And we have the data here with this very complete velocity and depth data set. We have the data needed to calculate a shear stress along the bed. So now I can take and put together a map just like this and start to look at where am I going to have issues of scour of sediment, of bed material. Where am I going to have issues of deposition of suspended sediment? If I'm interested in fisheries and aquatic ecology, the velocity is a very important parameter, and just what are my velocity distributions? What are the gradients? We have the ability to look at, and I should mention, to calculate a lot of these parameters throughout our reach as opposed to just one cross-section or one transect. So I can look at my velocities, I can look at my gradients. A lot of things like this, the door is open to really start to understand what's happening in a reach as opposed to be limited to just a very small number of data. And the problems of how I take my data points that I have and merge them together are being addressed here.
Great, thank you, Art. And as Art and Dana mentioned, you can easily get the WaterCube data into the Cubeit environment and take a look at the full reach. But you can also dive down and look at a particular section. We heard Diana talk about the subcube or the region just prior to the bridge, where they were doing some velocity indexing. So here we actually have that subcube, and this is the full volume data that was coming from WaterCube, and you can interactively drop in a section cut and kind of sweep it down this subcube to kind of give you some qualitative analysis of where the flow field is happening. Another thing that you can do is actually probe on that slice. So if you want some quantitative information on the velocity profile or any of the other parameters at that particular point, you can kind of probe along that slice interactively, and our probe tool will update. So that will give you very interesting information. You can also extract lines across that if you like. Another effective way to kind of look at a flow field when you have volume data is to use Isosurfaces, which is basically a constant value. Here we're kind of turning on the isosurface of a long stream velocity, so we can kind of step through the different values, and it'll give you some interesting insight into some thresholds depending on what you're analyzing. So that is an effective way. Maybe I'll pause there, and Art, do you want to comment on the slices and the isosurfaces before we jump into the stream traces?
Sure. I guess my first comment, as I look at this, we have for decades taken rather sparse data, and we want to see what's happening in a bigger volume, and so we develop computer models and try to somehow extrapolate or interpolate between the data we have. And to actually do this from real data at a density that makes this possible and then be able to visualize it is something we've wanted for decades but just haven't been able to do before. These, of course, the ability to probe any point means we can do calculations of other parameters. So you've got this list of long stream and downstream velocities. We have our X, Y, Z velocities, but that gives the potential to calculate a lot of other parameters that may be important to what I'm doing. One thing that comes to mind is the kinetic energy flux, which is the available power. So if I'm looking at hydropower generation, I now have the ability to look throughout my reach, my cube, and say, where do I have the greatest power available? In particular, some of the small-scale hydrokinetics that are being talked about. These isosurfaces, we very often deal with thresholds. I may be interested in some species that has a velocity threshold that this is the velocity that's preferred. I want to see what's the part of the river where this threshold is not exceeded. So right here I have the ability to very quickly see where am I above or below some threshold in the particular variable I've looked at. If I'm in geomorphology or river engineering or river restoration, what I may be looking at would be a scour. And the threshold of where does my scour exceed, that's what which is going to cause scour of the stream channel. We also, this data set doesn't have it, but the ability of the software to merge multiple platforms, multiple instruments means I could have water quality data. And so I could look at the same thing and where does my concentration of some constituent exceed a threshold, a regulatory threshold or some other threshold that I'm interested in. So a lot that can be done with this ability to interactively look and say, where is this going to happen?
Okay, thank you, Art. And then one other key thing that you can do in the Cubeit environment when you have the volume data is actually look at the streamlines. Here we actually have the X and Y, I guess, velocity components, so we can interactively seed streamlines throughout the subcubes to better understand the flow field where you're getting certain, mixing if that's of interest to you. So here we're kind of just dropping in some seed lines, and we'll turn on some timing markers here in a second. But I'll hand it back over to you, Art, because definitely streamlines and really analyzing the flow field throughout the volume can be very effective.
Yes, streamlines and the ability to do this is something we've used for a long time just to qualitatively understand what's happening. Where do I have areas of secondary circulation? Where do I have helical flow? Where do I have eddies and so forth? Looking at the dispersion. The ability now to take something like this and overlay it, we have our bathymetry here, and the streamlines make sense with the bathymetry we see. We could also take and make our background something, a water quality constituent. And now seeing where do we have mixing zones, we can start to understand here's the areas where a constituent, something that ends up in the water, is going to persist. Here's where it's going to move or dilute. One other thing that this can do is we can start to use this quantitatively. So our streamline is an integration of all of the velocity vectors. If we take something like this, and we have similar results from a model that we've developed, we now can do numerical to start to say how good is my model and move some of our model calibration away from, look, this you can see this is doing a good job, to where we have much more quantitative measures of how well is my model doing, and gives more confidence when we're applying a model to look at what if scenarios and so forth.
Great. Well, thank you, Art. So we've taken a look at the full reach, now, dove down to a subcube, and one thing that was collected at CJ Strike is 4 different flow events. So now we're going to transition into Cubeit Unlimited. So this is a framework for really bringing in your database of results across many flow events for easy and fast comparative analysis. So what we've done here is imported the WaterCube data into the Cubeit professional environment for 4 different flow events. So there's measurements taken on 4 different days. So now you have basically a database where you can easily interrogate and get qualitative as well as quantitative information. So here we're looking at what we call a matrix view of the cross sections by date. You can see the 4 measurement dates up on the columns, and we're looking at cross sections. So you can easily kind of scan to look for areas of interest. But one thing we know that a lot of people will do will dive down, and take a look at a particular cross section and find out what's happening when there are the different flow events. So we can here turn on the labels of these cross sections to give us a sense of our orientation. And now you can kind of look and pick a baseline case. These are actually raster images. You can pick a baseline case and perform a pixel for a pixel difference to give you a qualitative difference, to kind of give you a sense of what some of your deltas are between a baseline case and the other cases for that particular section across your 4 flow events. So a very effective way to look at comparative analysis. Or you can take that same cross-section and dive down and actually take a look at the cross-section data that comes out of WaterCube to do a more qualitative interactive exploration. So here you now have the same cross sections. You actually have the full data behind this, so you can again do probing and add contour levels and change any style things that you want. And again, a very effective way to look at multiple flow events in this type of environment. And I'll hand it over to Art to kind of comment on some of the things that a hydrologist could glean from this type of comparative analysis. Art?
Thank you. We're always looking for what are the dynamics of my system? How does this change? And so being able to look here and whatever flow events we've done the calculations, immediately comes to mind again is something like model calibration. That being able to look at multiple flow events, and I can look at my behavior throughout a cross-section, throughout a cube or a reach, and now among different events allows me a lot of power to take and calibrate my model, to validate, to say here's the kind of errors and uncertainties in my model results. Another thing that comes to mind just with these cross-section data is something along the lines of velocity indexing. I mentioned earlier that we want a site where we're very confident when I measure some small portion of this cross-section, it's going to have a constant relation to the mean velocity in the cross-section. So a tool like this lets me look and see how this behaves, and if I put my instrument at a certain point, that probe tool, I can compare how much change is there to the integration of velocities over the whole cross-section. So what we have here, I look at this site, and I don't know exactly where this is in the river, but one thing that stands out to me is a lot of it is fairly uniform. I would do some calculations and make this dimensionless so it's easy to compare one to another, but the software is giving me that ability. And so now I can say, this site, here's the kind of errors. If I assume this index is representative, I can look at different conditions and go through there. I can do the same kind of thing with a host of different variables. I might calculate a dispersion coefficient so I can look at mixing. I might calculate a shear stress or some other parameter, a habitat index that I'm looking at and seeing how does this vary from flow condition to flow condition. And so what's happening? What kind of variability and uncertainty is there in my understanding of this reach?
Well, thank you, Art. Now, if we go back to Now we're looking at the Cubeit unlimited environment. Another thing just to point out here is you can kind of look at some of the line plots, because again you have your database of cross sections with all the additional scalar values associated with those. So you can kind of look at different line plots of meaningful information along the 4 different flow events. So again, a very powerful environment for you to do qualitative and quantitative analysis. The last example I want to show you is just a short video of the same information that was kind of presented earlier. So in the Chorus professional environment, this is the Sacramento River reach where we pretty much brought in all the data, and now, you can dynamically, each of the frames is populated with data from WaterCube, and you can dynamically go in and explore certain regions, and you have different views, and then you can animate these frames, together over time, again, to build up that story that you can communicate with your target audience. So again, a very effective way to bring in all the layered data and present the views that you want. So Art or Diana, do you want to comment on this briefly before we open it up to questions?
I will just comment, once again, very often we're looking into understanding what's happening in my stream, and whatever our particular area of expertise is. And I said earlier, for decades we've tried to use models to do all of this and allow us to fly through a reach or look at different conditions. And what stands out to me is we now have the ability to do what we've often done with models using actual data from the stream and get asked some of the same kind of questions, get the same visualizations and animations that have already proven to be so powerful, but we're doing it based on data instead of models. And yet we do have the ability, we could merge now our actual data and model into one data set and provide even more insight.
Again, thank you for attending. Have a great day, and thank you, Art and Diana.